Imagine a robotic arm meticulously assembling a delicate component, or a mobile robot navigating a crowded warehouse. How do we precisely describe and control their movements so they do not crash or miss their target? Kinematic data in robotics refers to information that describes the motion of a robot's body or its constituent parts, such as joints and end effectors, purely in terms of position, orientation, velocity, and acceleration. Crucially, this data does not consider the forces or torques that actually cause the motion. This focus on geometry and time is fundamental. We distinguish between forward kinematics, which calculates the end effector's position and orientation from given joint angles, and inverse kinematics, which determines the necessary joint angles to achieve a desired end effector pose. This separation allows engineers to plan motion trajectories and avoid collisions without immediately diving into the complex physics of motor power or joint friction. Engineers and robot programmers utilize kinematic data to define a robot's desired path and trajectory. For instance, joint encoders on a robot arm provide raw kinematic data about each joint's current angular position and velocity. This information is then processed and used by control systems to move the robot to a target pose or to trace a specific path through space. A key concept related to kinematic data is the robot's degrees of freedom, which representing the minimum number of independent parameters required to uniquely define its configuration in space. Furthermore, the systematic description of a robot's kinematic structure often relies on parameters like those in the Dennevit-Hartenberg convention, providing a standardized way to model each link and joint relationship. Ultimately, understanding kinematic data allows us to accurately model, control, and predict robot movements. This ensures reliable and safe operation across diverse applications, making it the essential language for describing how a robot moves through its environment.
If you love robotics, like, subscribe, and keep building with us.